The scanner allows the bitmap entry of drawings, images and text, which can then be processed by programs. There are several types of scanners. The black and white scanner can be used to digitize grayscale images and the color scanner to digitize color images. In terms of its mechanical structure, it is manual, sheet-fed and flat-bed. The handheld scanner must be swiped through the surface to be digitized by hand at a constant speed. The advantage is that we are able to digitize not only flat, but also concave or convex surfaces with it. The disadvantage is that it has to be pulled evenly across the surface without shaking and is smaller in size, so it only scans smaller images at a time. The page feeder scanner feeds the page using the rollers, so you don't have to worry about scanning the image evenly, but you can only read thin pages. The most common scanner, the flatbed scanner, has a scanning area of the size of an image, usually A4 and A3 are used. Place the flat document face down on the glass and scan it with the scanner moving up and down. All three types of scanners work the same way. Using a fluorescent lens and mirrors, it illuminates the image at a minimum distance and width at a specified distance, converts the reflected light into voltage by a light sensing device, the CCD, coupled charge device, one filter for grayscale images and three filters, R, G and B, for color images, and then breaks it down into digital signals using an analog to digital converter. These components make up the main part of the scanner, the head. As this head traverses the image line by line, it sends all the scan data to the computer, giving us the digitized bitmap shape of the image. An optical character recognition (OCR) program is required for the computer to interpret the scanned text as text and not as an image. This program scans the scanned image and interprets and translates it where it finds a letter or punctuation that matches its character sets. The more character types the program recognizes, and the better the quality of the digitized image, the better it will recognize the text. The quality of a scanner is determined by how fine a resolution, how detailed an image can be digitized with it, and how many color pixels it has. Its detail, resolution, is given in dots per inch (dpi) and its color depth in bits. The maximum, optical, resolution of the scanner is determined by the number of light-sensing elements in the CCD, in the horizontal direction, and the degree of fineness of the movement in the vertical direction. The vertical resolution of a scanner is always double its horizontal resolution, usually 300 x 600, 600 x 1200 or 1200 x 400 dpi. A high-quality scanner has an optical resolution of 600 x 1200 dpi, a color depth of 36 bits for color images, and 12 bits for grayscale images. The resolution can also be improved by software interpolation. The interpolation procedure breaks the pixels into smaller parts and, after comparing the colors of the adjacent pixels, creates new color pixels by inference. This solution degrades rather than improves the quality of densely changing color images, e.g. photographs, but it can greatly improve the quality of line drawings and texts. The resolution and size that can be increased by interpolation can be up to 9600 x 9600 dpi. The color depth of the scanned image is determined in the same way as the color depth of the scanner, in bits, but its resolution is no longer given by DPIs, but simply in horizontal and vertical pixels, which is the size of the image, since the recorded pixels are elementary size. The higher the resolution, size, and color depth of an image, the more memory it takes up. Of course, images, like all data, can be compressed using different methods. How to calculate the memory allocation of an uncompressed image: resolution times color depth divided by 8. That is, e.g. a 300 x 600 pixel, 16-bit color depth image is approx. It takes up 352 KB of space. A digital camera is very similar to a scanner in terms of usability and operation, yet it is quite different. As with a traditional camera, you can capture images with a digital camera, but not on a roll of film, but in your own photo memory, and save the contents of the memory to your computer. Similar to the operation of a scanner, it converts focused light into a high-resolution CCD voltage, which is then digitized by an analog to digital converter and sent to photo memory, which can later be saved to a computer. Newer types of machines have expandable memory, up to 128 MB of memory, and can even capture images compressed, usually in JPG. The CCD resolution of the best machines reaches up to 3.3 megapixel. The resolution, unlike its scanner, is not determined in DPI, but in the usual way, in pixels, with which we can take images with a resolution of up to 2048 x 1536 pixels. Although this resolution is far behind the infinite number of resolutions for analog image capture, normal photography, with digital technology we can use far more effects, we can use higher zoom. And on the computer, digitized images can be retouched relatively quickly and easily with special image editing programs of our choice. Digital cameras usually run on battery power. Scanners and digital cameras generally communicate with Microsoft operating systems using drivers that support the most common standard, TWAIN, technology without an interesting name. The physical connection is made by the scanners, depending on their type, via the parallel port, USB, SCSI card or their own control card, and by the digital cameras via the serial port, parallel port or USB. The principle of the scanner. Structure of the flatbed scanner.